So welcome to 2021 question C3, of higher level DCG, and we have to draw the plan and elevation of the surfaces on the airplane A, B, C and D, the glass surfaces. We have to determine the dihedral angle between surface A and B. Then we have to draw the one-piece surface development of C and D and find a line QP that is inclined to 45 degrees in the horizontal plane. Now we can see our elevation of the roof surfaces here in SolidWorks. We can see our plan view. And we're about to see a pictorial view here now. And we're going to have to draw the plan and elevation. So we're going to set down our dimensions. We will draw in our XY line, plot our distances in plan and elevation. So I'm marking in my XY line, and going down about 25 from the XY line there to start my plan view. I'm drawing up a center line. I'm plotting the distances of, I'm going to plot 32 in just a moment. So 32, 30, 10, 15, 20 and 30. I'm going to draw lines across. Now I'm going to plot the distances 16, 44, 20, 10, 30, 10 on both sides. I'm going to draw the lines upwards. You can see me marking my 16, join 2 points along the bottom. That's the line of intersection between C and B that I just drew there. There we go. Intersection between C and D, down 10, across 12 for that diagonal. The plan view is, look, it is certainly self-explanatory on the distances to mark out. It can be a little bit more tricky to do in practice, especially the big area for your eyes conceive. Sometimes what might be an easier distance is, or an easier tip, is if you just focus on the right hand side and then use your compass to mirror the points across to the left. Like for example there, a little mistake I just made there, I rub it out, but you can use your compass to flip the points around, to make things a little simpler for you. That is easier. So we'll have our plan drawn in shortly here now. 12 across there, down 10, join them together. Now we'll do our elevation. So plot up 20 and 32. Careful not to do a 12 and 20. Bring your points up. And it can be a good idea sometimes now to use the question sheet just to help you figure out, what points will be what. There are the lines for the 20 and the 12 and the 80 going across. So you can see there, just sometimes that's handy in the exams. Just use your question sheet just as a rough guide as to what points join together. So that's an edge of the surface A, an edge of the surface on the left. I want to do surface C now. So that's surface C in elevation. That's the mirror image of C I'm doing on the left hand side. Now there's lines on surface A and B, the line of intersection between A and B in elevation. Now you see that up there, you see I should have only drawn that line on the top once. Shouldn't have needed to go twice. Now to get the dihedral angle, we need to look along the line of intersection. And you can do that in 3D by just looking along it. The line of intersection is going to project as a point. The two planes are going to project as edges. Now, you have to ask yourself, is the line of intersection a true length of plan and elevation? The answer is no, because it's not parallel to the XY line, plan or elevation. So I'm going to have to look perpendicular to the line of intersection, okay, which I'm going to do now. So I'm taking an auxiliary elevation. I'm looking perpendicular to the line of intersection. That's what you see down at the bottom. Okay, and then I'm going to look along the line of intersection from my second auxiliary. So the line that went orange there was my line of intersection. Now, so I'm going to draw in an x1, y1 line there. And I'm going to just shorten the surfaces A and B. Just take 3 points on it. A, B, C, D, A, B, C, D. And I'm going to project perpendicular to the line of intersection, and I'm going to get my heights from elevation. So I could use my compass to get these heights, but look, it's fairly simple to use your set square. 20 and 12, so I'm going to mark 20 from C and D. So that's C and D there, mark 20, and then an extra 12, so 32 for B, and then 80 from the x1 and y1 line for A. I'm going to join A1 to B1. C1, D1 to A1. You don't have to do it as C1 to A1 is heavy. It could be a light line. Now, I have the true length of my line of intersection here. So I'm going to look parallel to my line of intersection. And I'm going to take my distances from my x1, y1 line to, okay, plan view. Now in a moment. Now I'll use datum line. So I use the datum line on C. Okay, so C is on the x2, y2 line. Okay, the distance from C to D is 32 because it's 16 and 16. So I'm marking 32. Okay, and then 16 there. Alright, now we can join the points together. Get our protractor now and we'll measure the angle between them, which is, okay, 134, and that's my dihedral angle. Now we have to do the one-piece surface development between C and D. Right, so I need to get these both surfaces flat onto the horizontal plane. And I'm going to use these diagonal lines to help me find points on the surfaces C and D. They're called triangulation. It's called triangulation, and you can see the blue lines in 3D. And I will have to rotate lines until they're parallel to the XY line in plan to be able to find the true length of them in elevation. Right, okay, so I'll begin. I will label the points and identify what true lengths I have. A, B, C, D, E, F, G, H. I'm going to mark what lines are the true length. DT is a true length because it's a point in elevation. C to D is a true length in elevation because it's parallel to the XY line in plan. B to A is a true length in plan because it projects as a point in elevation. And A to H is a true length, as well as E to F are true lengths in plan because they are parallel to the XY line. Now you can see I'm joining these points together, okay, to act as diagonals there to divide the surface D up. Now, so I can start my surface D anywhere I want, so I'm just going to move it out to the side. So that's the length of DT because it's the true length in plan. Now I take D to C from elevation because it's a true length in elevation. So C1. Now I'm looking for B1. Okay, right. So I need the true length of D to B. So I'm going to get my compass and rotate D to B until it's parallel to the XY line in plan. So I'll put my compass on D and swing it around until it's the true length, or it's parallel to the XY line. I'm going to bring it up and B across. and I'm going to join D to B. Now that's the true length in elevation. So I'm going to take that distance, set my compass to D and swing an arc. Now I need to rotate C to B until it's parallel to the XY line in plan. I'm going to bring it up to elevation, and in a moment I'm going to feel like it's not accurate enough. So I'll join C to B one there, take the true length from elevation and swing from C. And I really feel like it's not accurate enough. So I'm going to do E to B. So I rotate E to B until it's parallel to the X1 or XY line in plan. Get the true length and elevation. And I swing the distance from E. So I'm going to join that C1. They're fairly close, the two of them, but I just felt it wasn't accurate enough. And then, of course, I copped on later. If you keep what you call it, the points parallel to the ones in plan, you can bring just B across. Okay, now I got B to A there from plan, and it's parallel to DT, as parallel lines are parallel in every orthographic view. So we're going to join the lines for the points together. That's a full line, that's a dashed line. Now we need to get surface C. I'm going to take the true length of A to H from plan, which is parallel to the XY line, and then I need to draw a diagonal there to get point H, the true length of E to H. So I'm going to get the true length of E to H now. And I'm going to swing it there, and now I have, okay, true length, or points A to H, sorry. I have now point H on the development. Now I need F and G. So I'm going to take my compass, get the true length of line E to F, which is already in plan, swing an arc. Now I'm going to get my compass, and I'm going to join A to F, get the true length of this line, so swing it until it's parallel to that XY line in plan. Okay, now I get the true length of that line A to F. I'm going to swing from A. That gets me point F. Now I just need point G. So I'm going to get the true length of line F to G and H to G. So I'll rotate them until they're parallel to the XY line. Get that true length line there, swing from H, that's the true length to H to G. Now I have them together. Now, and that's your development of surface D and C. Now for the last part, part D, okay, it's the same what we've been doing. So surface or line, that line there is 45 degrees to the HP. To see the true angle between the line and the plane, the line must appear as the true length. Okay, and the plane is an edge. So for the line, the 45-degree line, to appear as a true length in elevation, it has to be parallel to the XY line in plan. So I'm going to draw a 45-degree line from P, drop it down to plan, and it has to be on a line parallel to the XY line. I'm going to get my compass then. I'm going to put my compass on point P. I'm going to rotate the base of that line onto surface A. Together, and then I'm going to bring it to elevation. I'm going down 15 across, join them together,